Hi everyone, my name is Pavitra Suresh with a matrix number of S50928. I'm going to present a review on protein content in gelatin extracted from aquaculture fish species. Contents are introduction, literature review, result discussion, and conclusion. As for introduction, gelatin is defined as a denatured protein derived from collagen by thermohydrolysis. Fish gelatin is composed by a polypeptide chain that contains repeated amino acid sequences such as glycine, X and Y mostly as proline and hydroxyproline. It is a good material to hit the market due to its biocompatibility and can be applied with a minimal restriction. Protein content in gelatin depends mainly on the diversity of species that carries different properties. At the problem statement, the first one would be bovine spongiform encephalopathy, foot-mouth disease, and religious issues has made a drastic downfall on gelatin production in the market. With fish waste have almost the same amount of protein content as in the fish flesh. Fish gelatin is not commonly used as it is inferior to mammalian gelatin in rheological properties that affects the product quality. Significance of study in this review is improvising extraction of fish gelatin emphasizing on the protein content and contributes to the fish waste disposal management. Objectives is to review on the gelatin extracted from various aquaculture fish species and to review on the protein content and physicochemical properties in gelatin extracted from aquaculture fish species as suggestions for further research. Content of literature review is mainly about fish gelatin, applications of fish gelatin, aquaculture species, and protein. Method of gelatin extraction influences the yield percentage and functional properties of gelatin, where pre-treatment is very important in gelatin extraction, and that can be divided into acid and alkaline pre-treatment. When it comes to proximate analysis, protein, ash, lipid, and moisture content will be measured using AOAC method as a common method, and Jodal method is used in order to obtain the protein content. Amino acid composition will be determined using the amino acid analyzer. When it comes to gel strength, texture analyzer is used to record the maximum forces in grams. Gel color will be defined as L, A, and B, where the study strategy utilized in this review would be articles searched from Google Scholar, ResearchGate, ScienceDirect, and Springer Link. All articles collected were saved in Mendeley for easy access. Moving on to the study selection, keywords such as gelatin, fish gelatin, aquaculture species, physicochemical properties, and characterizations were used in order to extract information from the articles. Only articles published in English were selected in this review report. Lastly, data organization and reporting. One of the most important aspects for commercialized use gelatin is the yield percentage. From the research article, I was able to identify few types of aquaculture species used for gelatin extraction. Gelatins were extracted mostly from fish skins and bones. Extraction yield depends on the time and process of extraction procedure. The yield of fish gelatin is ranged between 5 to 80%, whereas low yield of fish gelatin may be due to the incomplete hydrolysis of collagen or loss of collagen during the washing process. According to Kariman Butt in 2009, increase in extraction temperature increases yield percentage, but it also caused a reduction in rheological properties. Protein is one of the main components identified in proximate composition, as protein is highly abundant in gelatin. Among the species reviewed in this study, protein content were mostly within the range of 60 to 80%. Protein content depends on the fish species along with extraction method used such as pre-treatment, temperature, time, and pH value. Meanwhile, commercialized gelatin have moisture content ranged between 9 to 14% because low moisture content can complicate the determination of the physical attribute. Warm water species have higher content of proline and hydroxyproline compared to cold water species. Hydroxyproline tend to show high gel strength since the amino acid is important in renaturation of gelatin subunit during the gelling process. It is also believed to play a singular role in stabilizing triple-stranded collagen helix due to its hydrogen bonding ability through hydroxyl group. In this review, gelatin extracted from cobia skin had higher percentage of hydroxyproline content compared to other species. Gel strength is one of the most important properties in gelatin for industrial and pharmaceutical applications. In general, fish gelatin have lower gel strength compared to mammalian gelatin. However, certain fish species such as catfish and yellowfin tuna have gel strength rated more than 400 grams. Mammalian gelatin extracted from pig or cow skin usually range between 100 to 300 grams. Low gel strength may be due to low content of proline and hydroxyproline, which could result in less organized triple helical structures. As conclusion, fishery and aquaculture industry generates large amount of byproducts with high gelatin content. Fish gelatin in warm water species contains high percentage of amino acids which are proline and hydroxyproline. Gelatin derived from aquaculture fish species have different physicochemical properties of gelatin. Fish gelatin has no sanitary and religious restriction. As for the recommendations, the yield of extraction in gelatin may be improved by using a standard pretreatment that can also improve rheological properties of gelatin. These are my references used.